The O-level syllabus for the physics, uh, it starts with the introduction of physical quantities. And the first topic, which is very important and very basic, is the physical quantities and the base units. So we will be starting our discussion by knowing that what is a physical quantity. How can we define a physical quantity? A physical quantity is the quantity which has a physical existence and it can be measured physically. For example, length or distance. It is a physical quantity. If I ask you that what is the distance between Karachi and Hyderabad, can this distance be measured physically or not? Yes. So since it can be measured physically and it can be told in a way that we can define this distance, so it is a physical quantity. It is an example of physical quantity. The distance between 2 points or the length of any object is a physical quantity. For example, someone says that the distance between Karachi and Hyderabad is 100 kilometers. So by using a number which is 100 and by using an appropriate unit, he is describing this distance. And since this distance can be described physically, so it is an example of a physical quantity. There are many quantities which cannot be measured physically. What we need to notice here is that when someone says that I love my parents, then this emotion or loving the parent, this cannot be measured physically. We cannot define this thing in such a way like we were defining this distance between Karachi and Hyderabad. Similarly, if someone says that I respect my elder brother, then respecting or respect is not a physical quantity and it cannot be measured physically. Same is the case with liking something. To like something is not a physical quantity and it cannot be measured physically. Hating something is also not a physical quantity and it cannot be measured physically. So when we discuss physics, we are mainly concerned about the physical quantities, the quantities which have a physical existence, the quantities which can be measured physically, the quantities which can be expressed using some number and an appropriate unit. These quantities are called physical quantities, base quantities. So there can be many physical quantities, infinite physical quantities, but 7 quantities are considered to be the base quantities. And what do we mean by a base quantity? So this is the definition of base quantity. A base quantity is a quantity which cannot be further broken down or expressed in the form of other quantities, in terms of other quantities. 7 quantities are considered to be the base quantities, which cannot be further simplified, and all other quantities are derived from them. So when we use the base quantities and we manipulate them and combine them in some in particular manners, then we get derived quantities, and I will be explaining it in a while. First, we will be writing down the 7 quantities which are considered to be the base quantities. So far we have discussed 5 basic quantities or base quantities: length, mass, time, temperature, and amount of substance. The units of these quantities are meters, kilograms, second, Kelvin, and mole. And the symbols are small m, small kg, small s, capital K, and mol. All the letters are small in mole. Okay, the next thing is light intensity or intensity of light. And the unit for this quantity is candela, and we write it as capital C and small d. And the last quantity is called electric current. And the unit for electric current is ampere, and it is written as capital A. These quantities are supposed to be the quantities which cannot be further broken down or expressed in simpler form or simpler quantities. These quantities have their units, and the units can be expressed using their symbols. Now, there is also one interesting thing about the last quantity I have written, and it is electric current. Sometimes students just write it as current, and they write the unit as ampere. So simply writing the current is not a base quantity, because current can be of many types, like water current, or some other sort of disturbance can also be called as current. So the base quantity is not simply the current or any type of current. The base quantity is particularly the electric current. Electric current is a base quantity, and this electric current has a particular meaning, and the unit of this quantity is ampere. Not every current has the same amperes unit as the electric current. All the other quantities which are not expressed in base quantities are actually derived quantities. So you see, there are many quantities, like we noted here volume. We also wrote here area, and there are also many other quantities which we are going to discuss and study in our syllabus. Many of these quantities are not written in these tables. Only the 7 quantities, the 7 base quantities are written here. So what about the other quantities? So we need to remember that all the quantities which are other than the base quantities are actually derived quantities. Base quantity and their units are called base units. And when we are talking about any derived quantity, the unit of the derived quantity is also going to be called a derived unit. For example, quantity of speed. And how do we measure speed? We divide the distance covered by time. Like, for example, if someone asks you the speed of the car with which the car is moving, and you answer, for example, the speed of the car at the moment is 80 kilometers per hour. So what is this kilometer showing? It is the unit of distance. What is this sign of slash or per showing? It shows division. And what do we mean by hour? It is the unit of time. So speed is basically derived using 2 base quantities. One of the base quantity is distance covered by some moving object, and the other base quantity is time. So if we want to write a unit for speed, we simply have to do one thing, that whatever the quantities are written in the formula of speed, we need to write the units for those quantities. So how many quantities can you see in the formula of speed, in the relation of speed? There are 2 quantities, distance and time. What should I write for the distance here? What is the base unit or the standard unit for distance? Distance is also basically a length. The symbol for meters is m. So m shows here the unit of distance or length. What should I write for time here? S means it is seconds. So it means that the unit of this derived quantity, which is speed, is meters per second. Or we can also write it as meters second inverse. So driving a unit of the derived quantity is not anything which is very difficult. If you just consider the formula of that derived quantity and replace the units of the quantities which are written in the formula one by one, then you can easily find out the unit of that derived quantity, which will be a derived unit, a derived quantity, and it is called volume. How do we find volume? We multiply length with breadth with height. So basically the three lengths are three dimensions, or the lengths are multiplied by each other, and we get the volume of a substance. So if I want to write its unit now, so when we multiply these three m's, we will be getting meter cube. So meter cube is the unit for volume, which should be used and which is derived from the base units, from the quantities which are written in its formula or its relation. I told you that the prefixes are used when we need to express very large quantities and very small quantities, and the prefixes that we need to know. The first one is tera. The symbol for tera is capital T, and it expresses 10 raised to 12, the quantity of 10 raised to 12. Then we have giga. The symbol for giga is capital G, and it expresses 10 raised to 9. So, for example, the capacity of a hard disk could be 1 terabyte. So, byte is the unit for measuring the space of the hard disk. And if we try to write this tera in the form of a number, then what we are going to do is we are going to write a 1, and then we will be required to write 12 zeros, because tera represents 10 raised to 12, and 10 raised to 12 means there are how many zeros with 1? 12 zeros. So instead of writing such a large number with bytes, what we did, we used a prefix tera, and we just wrote 1 terabyte, which represents the same quantity, the same space for the hard disk as it was being written with this very large number. Similarly, if someone says that the space on my USB is, or my Google Drive is 5 GB, or any other drive is 5 GB. So 5 GB means that we need to 5, and since giga represents 10 raised to 9, so we are going to write 9 zeros with 5, and this is the number which is being represented by 5 gigabytes. So instead of writing such a large number, we just wrote one prefix, and the calculation and the number became very easy for us to remember. Similarly, the next one is mega. The symbol for mega is capital M, and it represents 10 raised to 6. This is also used in computer hard disk space and other quantities. The next number is kilo, and the symbol for kilo is small k, and it represents 10 raised to 3. 10 raised to 3 means 1, we should write a 1 and then 3 zeros, so it will become 1000. So for example, if I tell you that the mass of some object is 5000 grams, so what you should write is that you should simply write it as 5 kilograms. So the number 1000 can be represented by this prefix, and this prefix is written just before the unit. So it is the prefix of the unit. Now, there are some other prefixes which are used to express very small quantities. Like the first one is deci. Deci is represented by small d, and it is 10 raised to minus 1. If we move this 10 in the denominator, the sign of the index will change. Okay, it would become 1 upon 10. So this 10 has a power of 1, which was negative in the numerator, but as we moved it in the denominator, the sign of the power changed. So 10 raised to minus 1 actually represents 1 upon 10 raised to 1. And 1 upon 10 raised to 1 means 1 upon 10 simply. And 1 upon 10 means 0.1. If you divide 1 by 10 in your calculator, this is the answer you are going to get. So now, if I am to place this number on the number line, so it will be placed, somewhere here, just besides this 0. It will be placed between 0 and 1, and it will be very near to 0, 0.1. Next prefix is centi, and it is represented by small c. And it means 10 raised to minus 2. The next one is, which is called milli. And milli is represented by small m. And small m, milli means 10 raised to minus 3. The next one is micro. The symbol for micro is this one, and it is equal to 10 raised to minus 6, which is equal to 1 upon 10 raised to 6. Then we have nano. The symbol for nano is small n, 10 raised to minus 9, and it is equal to 1 upon 10 raised to 9. And the final one is pico. The symbol for pico is small p, and it is 10 raised to minus 12, which will be equal to 1 upon 10 raised to 12. So the thing that we will be discussing in this lecture is basically the conversion. And this conversion will involve those prefixes which we studied in the last lecture. Okay. So, for example, if I give you a distance of 1000 meters, and if I ask you to convert this distance in a form where a prefix kilometer is being used, so how are you going to do this? How this conversion can be performed? So this is a conversion that we need to learn, how these prefixes can be used, and the number being used is converted into some other number. So the rule for this conversion is, if you are converting a smaller unit into a larger unit or bigger unit, so you always divide the given number. And if you are doing the opposite of this, if you are using a larger unit and you need to find out the same quantity in a smaller unit, then you will be using the multiplication operation. Let me explain this rule with a few examples now. Now, first of all, if I ask you to compare this meters with kilometers, which of them is smaller one and which of them is a larger quantity or a bigger quantity? Yes, kilometer is a bigger quantity while meters is a smaller quantity. And a very simple way to compare these two things is, you should imagine the length of 1 meter, and on the other hand, you can imagine a length of or a distance of 1 kilometer. So 1 kilometer is far too bigger than the distance or length of 1 meter. So it means that meter is a smaller quantity and kilometers is a larger quantity. So the first thing is that we need to compare the two units or form of units involved in the conversion. And we need to decide which one is smaller and which one is larger or bigger. Second thing we need to do is that we need to configure out what is the given form of unit. So the given form of unit is this one. We have been given with a quantity which is expressed in meters. So it means that the quantity is given to us, provided to us in a smaller unit or smaller quantity. And the third thing is we need to find out what is required from us, what we need to do. We are required to convert this quantity into a bigger or a larger quantity, which is kilometers. So these three things we need to analyze in every conversion. The first thing is we need to compare the two units, which one is smaller and which one is bigger. Secondly, we need to find what we are provided with. If we are given with the smaller quantity, we need to realize it. And if we are given with the larger quantity, we need to note that also. Thirdly, when we have found out what is given to us, then we need to find what is required from us. And now you can decide that in this case, we are provided with a smaller quantity and we are required to find the larger quantity. That we are going to use division in this case, because the rule says when you are given a smaller quantity and you need to find out the larger quantity, you need to divide. The quantity in meters that we are given is 1000, and the relation between kilometers and meters is 1 kilometer is equal to how many meters? So whenever you see kilo being written with any unit, you need to write a 1000 on the other side to represent this kilo. Meter is for meters. Kilo has been converted into numeric form, which is 1000. So 1 kilometer is 1000 meters. If we want to convert this quantity into kilometers, we need to divide it by 1000, and then the unit we will be writing with this answer is kilometers. Initially, it was 100,000 meters. Now, this meter is to be converted into kilometers. Okay, you can convert it, but for that, you need to divide the given quantity by 1000. And the answer we are getting here after this division is 100 kilometers. Now, let me give you another quantity. I need to find how can I write 100 meters into a centimeter. Now, the first question is, what is the smaller unit and what is the larger unit in this case? And the way to compare them is that we can think in our mind of a length of 1 centimeter, and we can think in our minds the length of a 1 meter. So 1 meter is quite larger than 1 centimeter. It is a larger quantity which is given to us, and the required quantity is smaller one. So what we deduce from these two things is that we are given a larger quantity or unit, and we are going to convert it into a smaller one. So when we convert a larger quantity into a smaller quantity, what we are required to do, we need to multiply here. Okay. Now, by which number are we going to multiply here? For that, we need to find out the standard relation which can relate 1 meter with the centimeters. So 100 centimeters is equal to 1 meters. And the given quantity is 100 meters. So 100 should be multiplied by 100 to convert it into a centimeters quantity. Or even we can write it here. We can multiply this relation with 100 on both sides. So 100 into 1 will become 100, and this will become 10,000 centimeters. So the answer is 100 meter is equal to 10,000 centimeters. So this was the other example. The first one was we were given a smaller quantity, we needed to convert it into a larger quantity. What we did was the operation of division. And now we were given with a larger quantity and we converted it into a smaller quantity by multiplying it. The way we need to solve it, that this is the case of a larger quantity being converted into a smaller quantity, and we need to multiply here. And the standard relationship says that 1 kilometer is 1000 meters. So using the standard relation, if I multiply both sides by 10, then I'll come to know that 10 kilometers is equal to 10,000 meters. So millimeter and meter, which one is smaller and which one is larger? Okay, it means that we need to convert a smaller quantity into a larger quantity. So we will be doing the division here. The relation which relates 1 meters with the millimeter is 1 meters is equal to 1000 millimeters. If I want to convert it using the same relation, I can do one thing here. I can move this 1000 to right hand side, and for this I can divide both sides by 1000. So 1 upon 1000 meters is equal to 1 millimeter. Secondly, if 1 millimeter is equal to 1 upon 1000 meters, now we can multiply the given quantity with both sides. That is, we can multiply 125 with 1 millimeter, and we can multiply 125 with 1 upon 1000 meters. So the answer we get here is 125 millimeters is equal to 0.125 meters. This is one way of doing it. Another way is that you just simply divide it by 1000 and convert the unit into meters, and the answer will be 0.125 meters. If we want to convert 115 decimeters into centimeters, so this is a conversion which involves two steps. So the easier way is if we convert 15 decimeters into meters, and then this meter quantity can be further converted into centimeters. That would be an easier way to do it, especially if we are practicing it in an initial stage. So, if we relate meters with decimeter, we know that 1 meter is equal to how many decimeters? 10 decimeters. So if we divide 15 by 10, it will be converted into meters. So the answer is 1.5 meters. Now we know that 1 meter has 100 centimeters, and this time we are converting a larger quantity into a smaller quantity. So we multiply it by 100. So it will become 150 centimeters. Okay, when we convert larger quantity into smaller quantity, we multiply. And when we convert smaller quantity into a larger quantity, we divide. So decimeter was a smaller quantity and meter was a larger quantity. So we divided here. This is the division. And meter is a larger quantity, centimeter is a smaller quantity. So we needed to multiply it. So we multiplied it this way. So sometimes the conversion involves two steps. Normally there are two steps if both of the units involve some prefix. If one side is not involving any prefix, like meter had no prefix, so there was a direct conversion. Like this meter had no prefix, there was a direct conversion. And all the other parts, one of the side did not have any prefix. But if you see there is a prefix on both the sides, then normally there will be two steps for conversion.